integrity is everything. Our way of life in this country rises and falls on the integrity of our leaders and the integrity of our infrastructure. Because integrity impacts everything, this is the Integrity Podcast, powered by EXO, hosted by Zachary, Oliphant.
Well, thanks everybody for coming back to the Integrity Podcast. I have a fantastic guest today. Josh Sebolt was a technical consultant with Burns McDonnell. Happy to have you here, Josh. So thanks for stopping by. Josh's background is 19 years in the civil engineering industry. He's done projects in almost half the states in the U.S. as well as work in Canada. Josh has done projects, everything from 34.5 kV up to 500 kV power projects. That's fun. A really diverse background there. He also sits on several committees and memberships. He's a member of ASC 48, vice chair of ASC's Electrical Transmission Structures Committee, overseeing the Manual of Practices. Also sits on the NESC Subcommittee 5, vice chair, and he's the vice chair of IEEE NESC WG7, as well as several other committees. Josh has given several technical papers, which is fantastic as we sit here at TS-DOS today at another technical conference. And Josh brings a really unique perspective to our industry because he started actually in bridge, and I'd like to hear a little bit about that, and then transition into utility industry. So, Josh, welcome.
Thank you.
Thanks for stopping by, and maybe we'll just start with your background. How did you, was there a seminal moment that got you into engineering? Did you like mathematics as a kid? Just walk me through that.
Yeah, thanks for having me. I grew up in the Kansas City metro area. I was maybe like a lot of typical engineers. You're decent in math. My dad's not an engineer, but he was always accused of being one because he was very, detail oriented, and so people would always just assume, well, you should be an engineer like your dad. So when you end up going to the University of Columbia, I'm a third generation Tiger. I got 3 kids. Pretty sure one of those will go at least. So we'll keep the tradition. Yeah, at least one. And so went declared engineering as civil engineering as a major. Well, really civil and mechanical. I couldn't decide. I was leaning towards mechanical because I like to work on cars, and I thought, well, that's what I should do. I took thermodynamics, and I got like a C in that, and I was like, well. That's supposed to be the introductory thing of mechanical, and I thought, well, maybe that's not for me, and so I said, I'll just stick with civil. So I did some internships with DOTs, but ultimately ended up, when I graduated, taking a job and working in like the private side for my whole career. And so at that time, I was thinking, every alpha civil either wants to design bridges or big buildings. Ultimately ended up being, I did bridges. And most of the bridges I worked on were in rural parts of Missouri, places you'd be lost if you saw my work. But I got to do all aspects of it, the sizing, working with landowners, which sometimes that would be people excited about a new bridge and some people not so excited. So I got to work in, hone some strengths as far as being able to try to find common ground with people who don't want maybe what you're offering. And so did that for about 5 or 6 years. And then, the economy started going down the tubes in 08 or 09. A lot of smaller firms started folding. And ultimately we ended up, getting acquired by Burns McDonnell. So I like to tell people I came to Burns & Mac kind of through the side door. Yeah. But it did give me some perspective of going through, before that happened, of just, going through some layoffs and some, gives you, puts things in perspective of life and having a job and providing for your family.
Absolutely. So you mentioned you were in bridge design and bridge work, and then you guys were acquired by Burns McDonnell. Yeah. What was the impetus to move into the utility space?
Yeah, it would. Yeah, that's a good question because it's that's kind of a big jump. The NERC alert happened around 2010, where it required utilities to look at everything above 100 kV, and Burns McDonnell was doing a lot of that, and there was an opportunity to work on that because that area of our business, our company, was very busy. And so I worked on that for 3+ years, and then it was a tough decision to decide. Well, okay, all I've done thus far is bridges. This industry looks like it's got no end in sight. at the same time, I don't want to burn a bridge of switching industries. But I thought long and hard. I was like, if I do this, I'm done, because I'm a long-term thinker. I don't make rash decisions. But ultimately, I decided that it was in the best interest. And so, but it also gave me what I call a healthy level of paranoia. So I'm at that point, I'm 7, 8, 9, 10 years in my career. All I did for 3 years was a very niche thing in T-line engineering or in PLS CAD. I was very good at one thing. We get done with that, and I'm like, I'm more further in my career than maybe somebody 2 years, but they know more about transmission line engineering than me. I was like, and so it just kind of lit a fire that I was like, I want to learn this. I want to know it really well so that I can catch up to be, where I thought I should be in my career.
Yeah, absolutely. Did you have any mentor along the way at Burns McDonald as you were making this transition?
I would say, I would probably say my most influential mentor was somebody who worked with me across 3 companies, more on the bridge side, named Jerry Stevenson, and he shaped a lot of how I do engineering now. He was the most detail-oriented engineer that I've ever known. He was always right. You'd always find my mistakes, and I always hoped I could find a mistake at Jerry's, because then I'd feel like I had accomplished something. But things I learned from him is just like, it has to make sense. It has to fit together. When we draw it out, it's got to be buildable outside. Yep. He also always made time. Like at the time when you're a new engineer, you ask 1,000 questions an hour. And at the time, I never realized he has other work to do besides answer Josh's questions. But I look back on that, and I've tried to do that in my career and kind of having a part of that being my job of taking time to answer questions and not just give the answer. I usually try to find what's the question behind the question, or caveat too, hey, normally the answer is going to be 6. Sometimes it could be 5 because of this, and if it's 10, maybe you run, type of thing, so that you're learning engineering judgment. Because I more would rather tell somebody, I use this analogy a lot when I was teaching my son, my oldest, to drive, is we covered a lot of fundamentals of, you should do this if this happens, instead of memorizing, okay, at this intersection, at this particular intersection, this always happens, because you're going to be at a lot of intersections in your life, and you got to understand your fundamentals. So I'm huge on fundamentals, because then you can apply them to anything else in life.
That's right. So as you think about your 20-year journey as an engineer, and now you're probably mentoring some young engineers, maybe give me some feedback there on how that is, kind of full circle, where you were mentored and now you're mentoring others. And obviously, you and I grew up in a different time technologically than young engineers coming in now.
Right.
Walk me through that.
I'm big on making sure that the output makes sense. We have software at our fingertips here that can calculate things very quickly. Maybe you could say too quickly. We both know Otto, and I love the software. And he would say this too: is you need to understand what the software is doing. I tell people a lot: don't let the computer be smarter than you. If you want to accelerate your career, understand how it did this. You can, and I do this with small groups that I meet with. Is you can. A lot of things in PLS CAD you can do by hand. You can calculate a sag of a single span very easily. You can understand how a steel pole capacity is checked. ASC 48, there's equations. The software is just using those equations. And once you see stuff like that, or even like a wood pole, you can figure out ASC's got a great guide on wood poles. You can understand that. Once you understand that, I feel like then when you see something go wrong that doesn't fit in your normal paradigm, you can be like, well, I understand that, or I don't, but I know where to look. So that you're just not, you have better context, I guess. It gives you great context to apply to weird things when they come up.
Yep, absolutely. And you mentioned in your bridge background, you mentioned several times about the practical application of engineering in the field. That's an area that some engineers really struggle with. Some engineers are really great at saying, hey, can we actually fabricate or build this? Not only cost effectively, but safely? Can we install it effectively? Maybe give me a story or two where that's applied in your career.
I had a lot of field work on the bridge side, a lot of windshield time to get some of that field work. And, the good thing about going to the field, they'll always give you feedback whether or not you ask for it or not. I'd always tell people, like, don't go out there and be like, well, I'm the engineer and, this is how it's going to be.
Yep.
You're going to end up at the bottom of the foundation, with that type of attitude. And so when you see those things, and sometimes if you can't make it in the field, you can learn stuff from YouTube. But get outside when you can and understand. Like there's several ways might be correct, but one of them or one of them is going to be probably impossible to build.
Yep.
I think it's a great skill if you can, when you have a construction detail or whatever, if you can put that together in your head, like literally, how is this pin going to go through this hole? Is that going to bind? What's my orientation? All these things. If all that starts to click in your head, then I think you can make a lot better construction details. Because the other thing too is, remember, let's say I'm right and I came up with a fantastic design. If I can't make it buildable, even if they're supposed to, let's say, was I that great of an engineer? If I could have come up with a solution that was perhaps simpler,
Yep.
that could be implemented a lot better and less likelihood of human error. I'm always like to remove human error if I can in the office or outside.
Yeah, no, absolutely. And what a lot of folks don't understand sometimes is an engineer or then a detailer after an engineer has maybe spent weeks or months on a design, and then a fabricator gets a very small window to get it right. And they're under extreme pressure with their welders and fitters and all those sorts of things to build it perfect, then get it in the field and then construct it effectively and perfect. And usually they haven't had the history that you've had with a project, so it's a very practical application. And you see some folks miss the boat on that, so it's good to hear. Now, would you recommend for young engineers go spend time in the field when they can, go visit with the field folks and all that sort of stuff?
Oh, absolutely. You will be a better engineer for it. Every time. I can remember sometimes, especially when it came like to pouring concrete and detailing how the reinforcement would be bent and placed. I could see practically that is hard to get the concrete there. It doesn't just show up on the next page of the drawings.
Yep.
And to something that you said just a second ago, and I harp this on our designs, is like, you can have a great design, but if the next person can't understand it, or Burns Mac, we're big on quality. We go through a lot of reviews. If your spreadsheet or your tool, maybe you think it's the best thing ever, but if I can't understand it or somebody else, or it can't be verified or used, is it really that great? There's some beauty and simplicity as long as, with the appropriate measures.
Yep, absolutely. So shifting gears a little bit to the power grid, and you've probably seen, like I have in my 20 plus years, the grid change a lot,
right?
With the advent of renewables coming on and battery storage and demands coming up, electrification of vehicles now putting more demands. Hottest summer, I think, on record,
right,
putting demands on the grid. Maybe kind of walk me through this complex system that we live in, and we all think it's easy just to flip a light switch and you've got power. Maybe some of the challenges around that and what you see the next 10 or 15 years of your career as you're fighting these challenges.
Yeah, so you mentioned, everybody's wanting an electric car, so we have 100 devices in this room even, and 3 of them on my body that I charge every night. So we definitely have more demand, and then I use this telling my kids this the other day. Kansas City Chiefs Stadium is at the intersection of 2 major interstates, and there's a bunch of roads leading up to it. So you can get a lot of people into that facility, relatively quickly, for a game. And even quicker if it's the Royals, because their stadiums are next to there. But if we take things offline that have been creating power for us for a long time, and we move them somewhere else, i.e. that move being solar, wind, or something else, and we move Chief Stadium to some suburb, suburb out by me where there's just a couple of residential streets in there, we have a need for a lot more transmission lines, and so. There's a need for more transmission. There is, but that's not always, or it's almost never exciting for somebody to have a new T line. So two answers. I think I don't necessarily have like how it's going to happen, but to permit a line can take 10 plus years before you start scratching the earth. So somehow that's going to have to speed up. We have existing corridors. We're going to have to find ways to put more juice down the same corridor. I think a answer possibly on some of that stuff is going to have to be conductor types that we haven't used predominantly, stuff that can take more ampacity without sagging as much. That's two things I think I see are going to have to happen to do all this stuff that's been decided for us.
Yep, no, absolutely. So walk me through maybe a couple of challenging projects that you've worked on, maybe an unexpected outcome or something that you learned about yourself in a really difficult project that you worked on.
Right. Well, I'm going to keep it a little bit broad on that, but some engineering fundamentals that I apply is that my function of my job, I review a lot of work or sometimes get pulled into difficult projects. And a lot of times that can be overwhelming for whoever was working on it or even myself. And so I just try to go through what are, when I'm decided or somebody's decided this is stressful or this is hard, well, what's causing that? Most of the time it's because of the unknowns or the variables. So, and this is a concept that works with all engineering. If you can understand your variables, limit them where you can, and then start chipping away at the edges. I mean, I sometimes I've kind of coined this phrase. I think I have. I like to work around the bounds of absurdity. If I can, if I have unknowns that are outside my control, well, if I assume the most absurd thing that's not likely to happen, do I violate whatever I'm worried about? And almost like if I had a rectangle, I'm kind of bounding it in and trying to hone in on that stuff. And so that's usually how I work through, because I'll get asked, part of my job function, I get a bazillion blinking Teams messages about random things. And so I'm usually asking a bunch of questions so that I can hone in, kind of like going to a doctor and they start asking a million questions to figure out that it's your patella tendon or something. So that's how I approach problems, is understanding what is the unknowns.
Okay, absolutely. And you mentioned a little bit Teams and technology and the kind of the change we've all gone through with COVID over the last couple of years. With the advent of AI and machine learning, how are you seeing that affect your daily work, or do you see any of that being implemented into what we're doing moving forward? And what do you think are maybe some of the risks or rewards of that?
I'm going to say I'm still a little. I think it's still a touch early on what AI will change for transmission line engineering. I definitely think that anywhere where there is remedial processes of number crunching, that's going to come into a role. Probably something where you're trying to optimize a solution, with computing power that 5 years ago we didn't have. I don't think so that would be cool. I don't know if that solves the problem of it taking 10 years to permit a line. So up until now, I found it to be very helpful for helping my kids with their math homework on math that I've since forgot. But and I've seen this too. I've read about it. I've seen it be completely wrong on the math. Something very simple. So I think there's a ways to go there before we trust it blindly.
Well, I'm happy to hear professional engineers struggling to help their kid in math, because I certainly struggle to help my older kids in math as well. So maybe walk me through an example. We talk a lot in our business about how integrity is everything, and maybe you have a story or an example about that. Obviously, in engineering, your entire career is built on your integrity, on your designs, on trusting in the work you're doing. Obviously, there's some quality checks and other things that come behind that, but kind of walk me through maybe an example in your career.
Yeah. So, I think it's definitely in a lot of ways can be tied to quality, integrity. I mean, there's a lot of definitions, but, something effective, doing the right thing, even if nobody knows or nobody's looking. And so I like to, when I'm mentoring folks or checking work and stuff, there can be things that somebody thinks that don't matter. And to be clear, I mean, with engineering judgment, you can decide, well, it doesn't matter, that there is a mosquito on the foundation or something. But there can be other things where maybe you don't think it matters today, but one thing we see a lot in our line of work is that you're going to do the same thing over and over again because somebody's going to move a structure. We have to change concrete to steel or whatever. And so being intentional about very diligently making sure everything's right so that I'm trying to limit human error. And especially too, we should, I would never do the right thing or want to do the right thing so that I could make a sale or that somebody think, better of me. But I will tell you this, that especially, and maybe you use like carpentry or something like, you can tell like a master craftsman use construction details that nobody would have ever seen unless you took apart their work. Mm-hmm. When you're doing things right all the time and somebody who is sharp has to deconstruct your work and they see it, I don't see how that's ever a bad thing for your professional, what people think of you professionally. Because when somebody sees, oh, they took the time and they did this thing right that they didn't think I was going to see. Mm-hmm. I mean, I'm going to trust somebody a lot with that because they did something right just because they should have.
Yeah, no, absolutely. Absolutely. Josh, any other kind of comments or questions you want to make? Shout out to your kiddos.
Yeah, if they ever listen, Tim, Silas, and Joanna, I hope you're getting a good laugh out of this. No, I mean, I think I would lead, that, if you're a young engineer and you want to advance your career, take something, Rome wasn't built in a day, but you can pick something, there's good resources out there. There's textbooks. If you're using PLS CAD, you could work through the manual. We're at a conference right now here recording this. You can read papers. I feel like when I started getting curious, I would ask questions. And when I couldn't get an answer that I liked after going to the darkest places of wherever, I was like, well, maybe I can figure this out. And most of the time I could, and I think you can too. I bicycle a lot, and one of the way I grind through miles is coming up with abstract ideas for papers and then trying to figure it out. Like, why can't I understand this, or what would I have to do? Sometimes it makes the bike ride go a little bit quicker, keeps my brain off of the hill I'm going up. Mm-hmm. But being intentional with your career, things like that, when you understand those fundamentals, I just think everything clicks. And things like, why is the structure controlled by this case? Does it make sense that we're applying this load this way? Does my client understand the ramifications of the criteria they have? That's to me where you are. AI can't tell you that, or I think. And that's a value of, I'm a consultant, our company consults for folks. That's a value of a consultant when you can tell them the why, the ramifications of the decisions you're making.
Absolutely. Well, awesome, Josh. Well, thanks for the time today. I really appreciate it. Thanks for sharing some insights in your background and your career, and looking forward to the next 20 or 30 years of your career.
Thanks for having me.
Yeah, thank you.